One of the more popular parts of the kotlinx.coroutines library is the Flow API, and while it can seem intimidating for newcomers, if you're already familiar with how collections and sequences work in Kotlin, then you've already got a great head start on the Flow API as well, because a lot of the same operators that you use with collections and sequences are also available for flows. So in this video, we'll see how you can easily make the transition from using collections and sequences to using flows. Here's a simple list of dates which get mapped to instances of local date, and that's from the kotlinx.datetime library. And then they get printed out from within the for-each function at the end. And I'll just run this to show that it does exactly what we expect. And one of the neat things about the collection API is that we can chain together calls to functions like map and for each, and these are known as collection operators. With collections, remember that we've got two different kinds of operators. We've got intermediate and we've got terminal. So in this code, map is an intermediate operator because it's called on a list and it returns a list. And then for each is a terminal operator because it's called on a list, but it does not return a list. Well, just like collections, the Flow API also gives us a way to create very similar operation chains. To see those in action, let's convert this from a list to a flow. Now, just like we've got the functions list of, set of, and sequence of, we've also got a function named flow of. And just like its collection and sequence counterparts, it accepts a variable number of arguments representing the values that are going to be part of that flow. Now, when you make that change, you'll notice that the call to map here is just fine, but we get an error with for each. When it comes to flows, the terminal operators are known as collectors because they collect the values from the flow and do something with them. The for each function doesn't actually exist in the Flow API. Well, technically it does, but it's only there to tell you when you're doing it wrong. So instead of using the for each function, we're going to use the most basic collector, which is a function that's simply named collect. And as you can see over here on the left, the collect function is a suspending function, and that means that it can only be called from another suspending function. And the easiest way to do that here is just to change the main function itself to be suspending. So let's do that. And with this, you can see we've got no more compiler errors. Let's go ahead and give this a run, and we'll see the same output that we saw before. With what we've seen so far, the biggest difference between a list and a flow is that the terminal operator down here, the collector, is a suspending function. Now, it's important to note here that the lambda that it accepts is also suspending. So inside that lambda, we can call other suspending functions. So for example, let's delay for 1 second between each of these items. And when we run this, we'll see a 1 second delay between each date that's printed to the console. So again, the collect function itself is suspending, and that means that we can only call it from a suspending function. And its lambda is also suspending, so we can call other suspending functions from it. Now, as you know, we can assign a list to a variable, and then we can call for each on that same list multiple times. So here, we're creating the list up top and then operating on it here and here. Well, we can do the same thing with a flow. In this code, you can see that I'm building up the flow right here and then operating on it inside the collectors here and here. The first time that we collect it, we delay only 1/4 second between values, and then the next time we delay for a full second. So when we run this, we'll see that the dates are going to come in pretty quickly at first, and then when we get the days of the week printed out, they're coming in more slowly. Now, as I mentioned, the collect function is a suspending function, so when we call it here and here, we need to be in another suspending function. But the flow of function and the map function, those are just building out the flow, and they're both regular old non-suspending functions. So we don't need to call them from a suspending function. In fact, we don't even have to call them from a function at all. We can simply move them out of the main function entirely like this. And when we run this, we'll get exactly the same result as we had before. So again, we can create the flow in a regular non-suspending function, or even at the top level like I'm doing here, but we can only collect the flow from a suspending function. Now, I mentioned that the Flow API includes a lot of the same operators that you find in the Collections API. But so far, the only one we've used is map. So let's add a few others that you're probably already familiar with. Here I've added a few more dates to our flow. So let's add a filter operation so that we can omit any days that are on the weekend. And we can also use the take function to limit our flow to just the first 5 elements. When we run this, we'll see that the printed dates omit the 7th and 8th, which fell on a weekend, and that only the first 5 elements were collected. Now, even though parts of the API are similar between collections and flows, their use cases tend to be quite different. Collections are used for elements that all belong together. So you can think of it maybe as a string of Christmas lights where each bulb is an element in that collection. All of those lights are joined together and they're contained together in the same collection. On the other hand, flows are better suited to represent changes to a single value over time. So rather than a string of Christmas lights, it's more like a single light bulb that can be set to different colors over time. So you might start with the color set to red, and so red is emitted into the flow, and then later you change it to green. So green is emitted into the flow, and then a little later you set it to blue, so blue is emitted, and so on. And that's what I'm doing here. Instead of using the simple flow of function that we started with, now I'm using this flow builder to emit those values with delays between them. And if you've used the sequence builder, you'll feel right at home with the flow builder. In fact, you could even model this with a sequence instead of a flow, but the sequence builder can't call the delay function. So instead, you would have to call a blocking function like thread.sleep. So there we go. As we saw, the Flow API can do a lot that the collection and sequence APIs can do, but also gives us the full power of the kotlinx.coroutines library. And that means that it also introduces several operators that aren't available on those APIs. So in the next video, we're going to look at some operators that are unique to the Flow API and see how you can start using them to do things that you just can't do with collections. And hey, if you're ready to take the guesswork out of coroutines entirely, take a look at my course about Kotlin, coroutines, and concurrency, and see if it might be a good fit for you or your team. I'm going to leave a link to that in the description. That's going to do it for today's video. Thank you so much for watching, and I'll see you next time.